Today, on how it's made. Engine blocks. We take a trip to the hood. Jawbreakers. Workers at this factory take their sweet time. Drum shells. We'll round out all the details on how they make them. And drums. We really get into the beat with this story. The engine block is the largest single piece of metal in a car, and also one of the most intricate. It houses and links all the engine components, such as the cylinders and pistons, and it contains passages for circulating coolant. The engine block is where combustion converts into mechanical energy that drives the transmission, propelling the car. Engine blocks used to be made of iron. Today, most are made of lightweight aluminum alloy for fuel efficiency. An engine block is a one-piece component cast from a sand mold. To make the mold, the factory mixes glue and a hardener with zircon sand. This combination of materials can withstand the intense heat of molten metal, but only for one casting. Each mold is made up of sections called cores that fit together. To make each core, a machine blows the sand and glue mixture into a master mold made of iron. It injects a gas that activates the hardener, which solidifies the mixture. This is the base core to which the other cores will attach. The base core travels down an assembly line to receive the other cores. The next core molds the engine block's cylinder bores, which will house the motor's pistons. A robot inserts iron liners into 6 holes in the core. They prevent the aluminum walls of the bores from wearing out from abrasion. The base core receives 17 other cores. The ones for engine block areas through which oil will flow are coated with talcum powder. This keeps sand particles from sticking to the aluminum and getting into the oil. The machines glue certain cores so they'll stay intact when the robots flip them upside down and attach them to the rest. These are the last 2 cores. The mold is now fully assembled and ready for casting. Workers load aluminum ingots into a device called an elevator bucket. It positions them above the jet melter, a gas-fired furnace. The bucket drops the ingots into the 800 degrees Celsius fire, liquefying the aluminum. Just before casting, they heat the cylinder bore liners using high-frequency electric current. Aluminum will bond better to hot metal. They fill the molds from the bottom to avoid contaminating the metal with aluminum oxide. Oxide forms when molten aluminum comes into contact with the air. Pouring into the top of the mold would expose the metal to oxygen, and the pouring action itself would mix in the oxide. After the casting, the molds spend 6 hours in what's called a thermal sand reclaim oven. That breaks down the glue so the sand falls away. The heat also strengthens the metal. The cast aluminum engine blocks emerge, needing just some minor finishing. Robots turn them upside down to spill out loose sand. Machines saw off the risers, extra metal that fed the mold cavity to compensate for the 7% shrinkage that occurs when liquid aluminum solidifies. Finally, computer-guided tooling equipment performs a rough machining of the metal. This brings the engine blocks to a near-finished state. The engine plant that buys them does the final machining before installing the engine parts. Every engine block this factory produces passes through an automated vision system that inspects the engine blocks to ensure they have no defects whatsoever. Jawbreakers, also known as gobstoppers, have preoccupied candy lovers for decades. You pop one in and slowly suck or chew through up to 10 layers of colors and flavors. Sometimes there's bubble gum in the middle for an even longer lasting finish. The larger ones are just for show. Most Jawbreakers are about the size of a golf ball. To make their bubblegum centers, a worker blends synthetic rubber with powdered resin, which will dissolve the rubber. He adds a thickener, a preservative, and an oil called soya palm stearine, so the candy won't stick to your teeth. After mixing and steaming at 148 degrees Celsius for 4 hours, the batter pours into trays to cool. Sugar, coloring, and flavoring would deteriorate in the heat, so workers add those later. There's enough of this base to make gum centers for 450,000 small Jawbreakers. After 24 hours, the batter's hard. Workers chop it up and blend it with corn syrup to make it softer and sweeter. They add 45 kilos of finished gum that didn't make it into Jawbreakers before because it wasn't the right shape. Now they add natural and artificial flavors, which can include lemon, orange, strawberry, grape, and even tutti frutti. Then they add icing sugar. It makes the gum smoother to chew than regular sugar would. Workers dump the batch into an extruder that shapes 2 continuous streams of batter called rope. Another extruder divides each rope into 6 hollow tubes. The cavity inside will become pockets of air inside the gum centers. The next machine slices the tubes into 1-meter-long segments. A mechanical arm pushes the segments into the channel of a forming machine. Steel rolls then slice through the tubes and shape them into balls. The balls range in diameter depending on the size of the Jawbreakers being produced. Air blows through perforations in a cooling tunnel to cool and firm the centers. Then they fall onto another forming machine, which restores their round shape. Other Jawbreakers have hard candy in the center. The machine that makes them works like the presses drug companies use to make pills. It feeds candy powder into dies, then applies up to 5 tons of force to compress the powder into a solid candy. Now for the rest of the Jawbreaker. First, they dump the candy centers into what's called a coating pan. They add a hot mixture of water, corn syrup, and food coloring. Then dextrose, a type of powdered sugar. The pan rotates for 20 minutes as warm air dries the ingredients over the centers. The factory repeats this step 10 times for each layer. Talk about a sweet ordeal. Making a Jawbreaker takes 4 days. Workers give this batch special treatment. They speckle these Jawbreakers with different colors, giving them what this company calls the psychedelic look. After letting the candies dry for 24 hours, a worker adds pinches of powdered carnauba wax. This gives the Jawbreakers a shiny finish. Sliced open, you can see these Jawbreakers have 10 layers of flavors and sugar surrounding either hard candy or bubblegum cores. They measure 5.7 centimeters in diameter, as big as a billiard ball. And if you're counting calories, forget it. A Jawbreaker is 90% sugar. Almost every culture has marched to the beat of its own drum. Drums have been part of different civilizations for thousands of years. The earliest drum shells were hollowed-out logs or gourds. Different sizes created different sounds. Today, drum shells are a little more sophisticated, but the beat goes on. To make drum shells, they slice an enormous rock maple log into several boards. Maple is ideal for making drum shells because its hardness allows sound to resonate fully. Each of these maple boards will be transformed into one drum shell. Workers feed the boards to a ripsaw, which cuts them to the correct width. This varies depending on the size of drum being made. Then each board goes into a planer, which shaves it thinner. A worker aligns the board with markings on a saw table. This positions the board to be cut to the correct length. A radial arm saw does the job neatly. Now he sizes up each board in preparation for tapering. He places a board on an angle in a jig and then moves the end against a router cutter to taper it. It takes a few passes to get it just right. The taper needs to be about 15 centimeters long. He thins the other end of the board to the same dimension. These tapered ends will make it easier to bend the wood into a drum shape later. They'll also act as scarf joints, which will fasten the ends of the board together when it's bent round. But first, this board needs some softening up. An hour in the steam box does the trick. It's pliable enough to wind around a hot cylindrical form. Steel banding secures the board to the bending form, where it will spend 10 to 15 minutes. A worker pries apart the ends and applies a generous amount of glue between the tapered tips. Then he removes the shim that was holding the ends apart so that they stick together. He places a wooden guard over the glued joint. This nylon mesh band is a clamp. He wraps it around the drum shell and turns a screw to pull the band tightly around the wood until it reaches 35.5 centimeters in diameter. Then he fastens over a dozen steel clamps onto the joint. All these clamps will prevent any gaps from occurring in the joint as the glue sets overnight. With the joint sealed, the drum shell now spins while a cutter shaves down the edges to make it a true round shell. Then they bring in another cutter. It bores into the shell, making a smooth edge and rounding the inside. turns the drum shell around to cut it from another angle. As the shell spins, a high-speed cutter shaves the outside from top to bottom. This makes the surface very smooth. It takes about a week to make a drum shell from solid wood, and it'll be able to stand up to a real beating. There's more than one way to beat a drum, and there's more than one way to make one. Earlier, we showed you how they create a drum shell from a maple plank. But a newer technique involves layering multiple plies of wood. This process is called laminating, and you can hear the difference. The laminated drum is an instrument of change. Its sound is crisper than a drum crafted from a single piece of wood. To make one, they layer 11 sheets of maple. Here, a worker glues on the final ply using a special adhesive. This outer layer is luxurious bird's eye maple. Rollers press all the layers together to ensure they stick without any gaps. Then they cut through the overlap to create a perfect seam. A robotic drill now takes over. It drills holes of various diameters. The small ones will hold hardware. This larger one is an air vent. A computerized router then cuts the bearing edges to a 45-degree angle, and a worker sands it smooth. He uses a level surface to ensure that all the edges are perfect. If they're not, the drum heads won't fit properly. He applies an adhesive to the air hole and inserts a plastic vent. Next, he inserts brackets called lugs into the other holes and screws them in. There are 10 lugs spaced 36 degrees apart. They'll hold the rods that will attach the heads to the drum shell and also enable the drummer to adjust the tension on the heads. Here, he attaches a lever to control wires called snares that are to be strung across the bottom head. It's called a snare strainer. Then he fits a plastic drum head over the bottom of the shell. The counter hoop goes on next. It has little tabs, which he aligns with each lug. He slides tension rods into the holes in the tabs. Using a drum key, he tightens the head to an even tension across the shell. Now he blasts it with a heat gun to shrink the plastic and remove any wrinkles. Now he places another plastic head on the top bearing edge. Since this head is the one that gets pounded on, it's twice as thick as the bottom one. He places the chrome rim on it and tightens the tension rods. These brass brackets will hold the snare wires. He slides them under the snares that are stretched tightly across a jig, putting one at each end. He measures the length, then solders the snare wires to the brackets. He snips the wires on both ends and unlocks each wire from the holding device. When he removes the snares, they're held together by the brackets. He slides a nylon strap into one of the brackets, then attaches the strap to a fixture just above the bottom head. The other end of the snare is attached to the strainer, the lever that will apply tension and release it, controlling its distinctive buzz. For a bigger sound, there's the bass drum. It's made with wooden hoops. They attach the hoops to the drum shell with steel claws. As they screw the claws to the hoop, the drum head is pulled just tightly enough to produce that low-pitched bass drum sound. A sound production indeed.